First of all, I'd like to thank the organization of Oper8IT to have me here. I am a bit of the herald of doom across Europe with the topics that I bring on board, and today will be no exception. So I expect you all to be properly depressed by the end of my keynote. Don't disappoint me. Many years ago, this very entrepreneurial individual called Ted Kaczynski decided, quite correctly by the way, that machines would one day take over humanity. They would rule humanity. And because he was quite an entrepreneurial individual, he decided to do something about it. And he did so by sending a number of bombs to some reputable scientists and academics that were developing automation technologies, which earned them the name of the Unabomber. Thing is, when he was finally captured, he had a manifesto, and his manifesto was not one of a deranged man. You see, his manifesto did not propose that machines would take over in a Terminator-like fashion, in which they would create a Skynet and destroy us all with warfaring machines, but rather that we would create societies that would be so complex to manage that we would willingly hand over control to the machines. Now, as part of my work with the European Commission, with the European Research Council, we aim to predict the future and to predict what technologies should be invested in Europe. And therefore, in 2015, I developed a model, a framework, in which I could try to predict, or at least get a glimpse on how correct Ted Kaczynski could be. And I created this model, which is akin to Maslow's pyramids of needs. But here I strove to create a differentiation of human activity based on the variable of cognitive effort. It has 5 levels, and it starts with level 0, which is the level of no cognitive effort. Here we have the activities that humans commit to muscle memory. We just repeat the same physical activity over and over again, and thus reducing almost to 0 any decision-making that is required in the process. We recognize this type of activity in, for instance, agricultural activity and factory cereal production that, as we very well know, has been in large numbers replaced by automations. Before, in the late 19th century and early 20th century, with the Industrial Revolution and the impact of the Industrial Revolution in agriculture, the industrialization of agriculture, which moved at the time about 90% of workers displaced them from their previous activities. And nowadays, once again, this level of cognitive effort in human activity is once again being challenged now by general purpose robotics. As you can see there, this is a robot developed by ABB. It is basically 2 arms. And the reason why this robot is important and is disrupting, once again, manufacturing is very easy to understand if you trace a parallel with what happened with computation. We used to have these extremely large, quite good and specialized computers in banking, in rocket science, that were very good at what they were doing, but they were very expensive because they were custom made. They were very specialized for one activity, for one process. And then came general purpose computing. And we created these computers, the PCs, which were not as good as those machines by far, but they were good enough. And they were good and flexible enough that now we could apply them to a wide range of solutions. And by the fact that we could produce over and over again the same type of processor and computer, brought the price down to a point in which, even though they were not efficient, now we could afford to just buy more of them and cover the efficiency gap. Same thing happening with robotics. And if you doubt it, This same model from ABB was bought recently by this company called Foxconn. Foxconn, Taiwanese company, operates in China, 1.2 million workers. They assemble your iPhones, they assemble your Samsung phones. They are the electronics assembly company in the world, and they bought 1.4 million of these robots to replace Chinese workers. Now, when we reach the point in which it is economically viable to replace Chinese workers, we know we're onto something. The next level is a level that millennials and generation XYZs never got a lot of contact with. This is the level of repetitive cognitive work. We used to have in banks these large rooms filled with people that were doing math and accountancy by hand. We used to have these huge rooms filled with office admins that were copying letters by hand or using a typewriter. Nowadays, after in the 90s, late 80s and 90s, we had the office productivity revolution. Nowadays, those rooms are replaced by one spreadsheet or by a printer. And although we almost never realize it, but this represented a huge displacement of work during the 90s. These people needed to be upscaled because there was, especially in the early 90s, a huge wave of unemployment that resulted from this transition. Now it's where we are, level 2. Level 2 is the level in which humans are serving as interfaces. Interfaces between chaotic systems and non-chaotic systems, where we define a chaotic system as a system that has too many permutations that we can, encompass. Whereas a finite system or a non-chaotic system is one that has a finite number of permutations that we can reliably predict how, given a certain input, what the output will be. A good example of this is, of course, driving. When you're driving, anything can happen. You can have a UFO land in the middle of the road, and it is up to you as a human being to map the correct reaction into the finite number of operations the car offers. Steering wheel, 3 pedals, a gearbox. Same thing happens, for instance, if you have a customer service representative in a call center. You will have someone calling, asking for pretty much anything. Someone can call Vodafone and ask for a pizza. And it is up for this CSR to understand within the processes available inside the company which ones should be triggered to respond to that input. Now, most of you know, and that has been widely discussed already in this conference, that this level is also under attack by heuristics-based automation, by machine learning, by self-care. I would like to have a quick show of hands. How many of you have physically entered a bank in the past year? Okay, not so bad. It has been happening less and less, and this means that a lot of people that were before doing this interface job are now having to find other things to do. And again, we go into autonomous transportation. Autonomous transportation, not only cars, but also airplanes, ships, trucks, represents 11% of all jobs on Earth. And it is not a surprise for anyone here that nowadays, the autonomous cars for personal transportation are really not the low-hanging fruit of transportation. It's a lot easier to automate a trip made by a ship, for instance, that spends literally weeks at sea trying to keep a straight line. Then we have the next level of human activity, which is interface between chaotic and chaotic systems. Here, of course, when I refer to chaotic, I do it somewhat freely, just because the type of tools that people work at this level are complex or flexible enough to allow an infinite number of permutations. We only have so many reserved words in a programming language, but the combinations of these can produce pretty much any outcome. It is extremely complex. So it is up for an engineer, for instance, to perceive a chaotic world, which is the requirement space, which is practically infinite, and to map this into a solution space, which is also pretty much infinite. This is the realm of engineering. This is where it's still kind of safe for now, although it is now being attacked by low-code tools, by all sorts of automations, functional languages, that although for now we are not really still feeling the impact of this because demand is increasing fast enough, it is happening. It is an ongoing trend, and we'll see how much it is an ongoing trend. And finally, we have cognitive level 4. This is the creative level. This is where you put the artists. This is where you put the researchers. And I include here the researchers because they tend to create their own tools. So they tend to go to create more wildly chaotic space they work with because they're not at all limited by their tool sets. So people that know better than I do, namely the World Bank, predicts that this will be big in about 10 years. In black, in this graph, you will find in the 3 largest economic blocks in the world current unemployment rates, and in white you will find jobs at an elevated risk of automation until 2030. That's 10 years from now. We're not talking about, a nuclear fusion that's always 20 years in the future. This is something that is well within the realm of the possible. And if we think that this is what is coming, we can perhaps start looking at the past to realize that this is actually what has been happening, just in a way that we haven't been aware. You will notice this is the industrial output of the United States, Sweden, and Japan, and put against the employment of the industry in these 3 countries. And you will notice that since about 1985, although output has continued to grow, employment has decreased. So what happens when you have more output and you have less input? It's called increased efficiency. How do these efficiency gains are attained? Mostly by automation. And now bringing this to the topic of this conference, IT and operations. We see that when our friends at Gartner, that always are trying to predict the future and making a lot of money out of it, when they started asking what are the most important benefits that an automated operations center can have, of course we have cost reduction and productivity leading the way. And cost reduction and productivity are 2 words that mean we are going to be having less people doing stuff. Fortunately, most people disagree with that, although for now, a study performed by Fujitsu shows that most professionals believe that automation is a good thing. It actually is, I agree with that, because it will remove the most repetitive tasks from being performed by human beings, the old monkey work, and they believe that it will not reduce the number of workers working in operations because demand will continue to increase. Now that may be true for a while, and we have seen in agriculture and in other industries that was actually true for a while. But once the curve of demand stops expanding exponentially, which usually happens when you cannot grow infinitely, as in the case of when you live in a finite planet, in which infinite growth is just not the thing. And we are now discovering that Mother Nature is giving us a whooping and a lesson on that topic. When that demand curve stops rising fast enough and stops overtaking the curve of efficiency gains, jobs will start to suffer. So this raises an important issue, which is worldwide, and if we look at history, we learn that there are no societies that survive 30% unemployment. It is just not a thing. If you look at Venezuela, most recently, which is a country that has no qualms in, putting down revolution with violence, and still revolution continues even though we have violence. Because once you have about 30 to 35% unemployment, it means that 1 in every 3 people is unemployed. Everyone feels the pain of it. So everyone is unsatisfied. So we are looking at a society that is tending towards high rates of unemployment. Going back, right now we are on average in the world about 7% and 7 to 8% unemployment. If you just add on top the driving of stuff and the piloting of stuff, that's 20% unemployment right there. If you take, for instance, customer service representatives, sales, call centers, that's 14% of employment in the developed world. You add these two together with current unemployment, and that's over 30% already, So we're not talking about pessimistic scenarios, we're talking about something that is well within the realms of possibility. If that happens, we need to do something, and we need to do something right now. Because during these transitions is where usually society tends to collapse in some way or form, usually by eliminating democracy, taking it out of the way. There are some attempts to address this problem. One of them is the universal basic income, which is the premise in which just because you exist, you are entitled to get some money, regardless of you working or not. So if you work, you get something on top. If you don't work, you just keep what you have. And some experiments have been done with this system, some more successful than others. But the main opposition to this potential solution is usually presented that people will just stay home and watch Game of Thrones, which in the experiments that were performed was true in 20% of the cases. In about 60% of cases, people continued to work, but they started working less hours and dedicating more hours to their loved ones and the things they liked and enjoyed doing. And about 20% felt safe enough to start their own businesses and become entrepreneurs. The second opposition to this concept comes from economists that say that this system just is not sustainable. Well, I disagree with that. And I disagree with that because as you automate the entire supply chain, and I mean, if raw materials are being extracted by robots and they're being transported by robots to factories that transform those raw materials into other stuff using robots, that transport them to retail spaces that are mostly robot operated, it means that the cost of products and services will tend to match the cost of operating the robots, because the capital expenditures, the capital cost of acquiring the robots will be distributed by a huge number of units. Therefore, we will tend that these operational costs will tend to be those of the energy of operating robots. And if we have sources of energy that are cheap enough, then material wealth should be cheap enough that we could potentially provide sufficient quality of life from a material point of view to a large number of humans without needing to bankrupt our systems. But there's another point that is more complicated, which is how do we handle this as society? When you meet someone new, and this is a venue where that is happening a lot, the first question you ask, of course, is, what's your name? The second question you ask is, what do you do? And usually the answer comes in the form not of, I work as something, but comes in the form of, I am something. I am an engineer, I am a doctor, I am an operations guy. Because to society and to ourselves, we tend to identify ourselves with our activity. We tend to make what we do that is perceived as productive, as being part of our identity. So how are we going to organize ourselves as societies when we will not be employed for no fault of our own, but just because society does not allow us to? How are we going to project ourselves as useful members of society and be embraced by society under these conditions? Of course, now that I believe that I've depressed you enough, there are some things we can do about it. And one of the things that we can do about it is try to look at biology and see what biology, which is, you know, all about managing change, that's what evolution has been doing for a while, how do these things get tackled with? So we learned from biology that stability fosters growth. Whenever conditions are stable, there's usually an outburst of life. We look to history and we see that whenever this happened, those were the periods in which you had, you know, life really reaching out and taking over the planet. And we are in such a period. If we look at this graph, this is number of deaths due to conflict worldwide. We see that, you know, right there, we are at an all-time minimum of deaths that are related to conflict worldwide. The world has never been safer. That's just a fact. And this growth tends to foster specialization. So when your environment, when your ecosystem is extremely stable, it allows you to create very special tools to take the best advantage possible of the conditions that you have. And we realize that has also been the case. So as we had this time of stability, people have become more and more specialized in what they do. And this specialization has allowed them personal success, of course, due to the fact that we have these niches, these ecologic niches that are being fulfilled. Thing is, with specialization comes vulnerability. Because once you are extremely well adapted to a certain ecosystem equilibrium, if that equilibrium gets disrupted, now you are left with a set of tools that do not adapt, that do not match changing conditions. Thing is, humans are the ultimate adapters. And although we have this adaptation instinct, our careers usually point us towards the way of complete specialization, thus making us more vulnerable for changes in the labor market. So one thing that we can do is we can broaden our minds a bit, we can become a bit more flexible and a bit more adaptable. Another thing that we can do is we can use technology as an expander of human capability. And one of such examples, which has been also presented here by other speakers much better than I will, is what is called usually the intuitive AI, in which AI and humans are working together, supporting one another. AI is coming up with pattern detection, is coming up with predictive solutions, and then submits these solutions for humans to make decisions on. And usually this interaction produces extremely good results, better results than the humans or the AIs alone. So there is some space here for humans to remain relevant by, you know, coalescing with AI. We have one obstacle, but we are overcoming that obstacle as well, which is the obstacle of bandwidth. We are all bandwidth limited because we have some input sensors, you know, these two, and we have this bandwidth to communicate with this device, which is we have two output devices, which are these two. So we can already do quite a lot, but we're still limited by the number of words we can read or number of sounds that we can listen per second, and by the number of letters that you can write with your thumbs. Although my son clearly has me there. He's quite faster than I am. But we have this bandwidth limitation, which limits our ability to make full use of what machines can provide us as enhancements to our working ability. Of course, that is being addressed. One of the people addressing that is our friend Elon Musk. by the creation of something called the brain gate, which are literally implants that you will put inside your skull. These are already working, by the way. We are already doing amazing things with these. We are already able, in humans, to control stuff using these implants. Basic control, up, down, left, right, writing a few words. We are able to do some very interesting things when it comes with image recognition, so we can actually extract from the brain the image that you're watching, quite reliably. In rats, well, rats always get the good stuff, right, first. In rats, they are now able to transfer memories. So you can teach a rat with an implant similar to this one how to exit the maze, and another rat, which is connected to this rat with a similar implant, will find the exit first try. So we are already in the realm of memory sharing, and we're working our way there. But if we believe that this is going to work, and I do believe this is going to work, then we start tackling the issue of control. Because I believe that I control my computer. And why do I believe that? Well, my computer is a very specialized machine. It is very good at doing calculations. But I have control because I control the inputs, or at least I believe I do. And through the inputs that I provided, it provides me with a set of outputs which are, well, at least in theory, determined by the inputs I give it. Therefore, I am in control. I control the inputs, I control the outputs. The computer is merely performing a task for which it is highly specialized. But if now we are going to start having machines giving us the inputs, and we will believe those inputs blindly, and believe me, we already do. If right now all of you got a message saying that there was a shooter out there shooting people, even though none of you saw the shooter, we would collectively believe that would be the case, and we would be running, just because our mobile phones told us. So we will be having inputs provided into our brain by machines. And we will be providing what? Well, most probably decision making. And that will be our output, decision making. So if you look at this from the perspective of a system, won't we at that time have become a very specialized coprocessor for the machine? A decision-making coprocessor, a biological coprocessor for a much larger system. And in that day, will we not have become what the Unabomber said, controlled by machines? So in our quest not to be controlled by machines, will we not be, again, exposing ourselves to be controlled by machines? Well, I don't have an answer for this, nor do I have a solution, but I do have a belief. And that belief is that in every religion that has a concept of paradise, in that paradise, humans don't work. So there is something in the human psyche that correlates not having to work for a living, not having to be meaningful through work, as something highly, highly desirable. And therefore, we could be well in our way towards that paradise, or not, depending on the choices we make. And what frightens me is, throughout history, whenever there was a highly disruptive technology that could completely change society, the people that yielded that power became philosophers. They got engaged in the discussions. When war was the main tool for societal change, we had the warrior philosophers. When politics became the tool of societal change, we had the politician philosophers. Well, nowadays, there is nobody better suited to understand the potentials of technology than you. And we need to have techno-philosophers. We need to have technology people involved and engaged in the discussions of the consequences of the tools we are creating, to try to steer policy making towards making the best use of our tools to create an idyllic future rather than a nightmarish one. That is all.